Alright, so we are starting section 1.4, continuity and one-side limits. This video will look at continuity at a point, continuity on an open interval, and continuity on a closed interval. Okay, so before we even begin, when you think about continuity, intuitively basically just means that it's a graph. Without any breaks, holes, or gaps. Okay, so basically the graph can be drawn without lifting your pencil. Okay. Alright, so let's first talk about continuity at a point. Alright, a function is continuous at a point C. If the following things hold true. 1. The limit as x approaches c of f of x exists. So basically that means the limit as x approaches c from the left-hand side of f of x has to equal the limit as x approaches c from the right-hand side of f of x. Okay. Number 2, f of c has to be defined. And number 3 may kind of seem obvious, but if you have some function, so far you're saying, okay, the limit exists from the left and right hand side, it's the same, but an f of c is defined. You could have a situation like this where it's not really continuous. So I'm going to say the third stipulation is the limit as x approaches c of f of x actually has to equal f of c. So that means that hole would no longer exist and it'd be the same thing. Okay. All right, just review a little bit about open and closed intervals. So continuity on an open interval. If you remember interval notation from pre-calc, we're going to say that a function is continuous on an open interval. So we're just looking from A to B. We don't really care what actually happens at the endpoints, just in between. So here we would say that it's continuous on the interval a comma b. We're going to use parentheses. However, it is not continuous on the interval using brackets a comma b. Okay, next thing is we'll look at continuity on a closed interval. Okay, so if you think about a closed interval, that means that the endpoints have to be included. So some interval from A to B. The function needs to be continuous and it needs to include the endpoints. So it's going to be continuous on the open interval AB and the closed interval AB. And I'm just going to say a function is continuous on the closed interval a comma b if it is continuous on the open interval a comma b and the limit as x approaches a from the right hand side, right, because we're coming from the right hand side here, of f of x has to actually equal f of a, and the limit as x approaches b from the left hand side, because we're coming from the left hand side here, of f of x has to actually equal f of b. Okay, so let's look at your worksheet if you are here in Calc Honors, and we'll do a couple of problems together, make sure you got the hang of it. How do we do the odd ones? So if you are in Calc Honors and we're looking at the worksheet practice with finding limits, and we'll look at maybe the odd ones. So look at number 1. The limit as x approaches 0 from the right hand side of f of x, and f of x equals x squared for when x is less than 0 and 4 when x is greater than or equal to 0. All right. Coming from the right hand side, that means we don't need to worry about that first function. We're just looking at the second one. So as we approach 0 from the right hand side, it's just going to equal 4. Okay. All right, number 3, just doing the odds right now. The limit as x approaches 0 from the right hand side again of f of x, and f of x equals 2x plus 5 when x is less than 0, so that'd be coming from the left hand side, and then negative x minus 4 when x is greater than or equal to 0. So again, we're just looking at the second function. We're going to try to plug in chug, so we'll plug in 0 for x. Therefore, our limit would just equal negative 4. Okay, number 5. The limit as x approaches 0 of f of x, given that f of x is going to equal, let's see, x minus 2 when x is less than 0, x minus 2, or x over 2 minus 2 when x is greater than or equal to 0. Okay, so we need to actually make sure we have the same limit from the left and right and use a different color. So as we come from the left hand side, I'm going to plug in 0. Let's see, 0 minus 2 is negative 2. So come from the right hand side, if I plug in 0, I'm going to notice that I have the same value from the left and right hand side. So the limit exists, and that value is going to be negative 2. Alright, let's see, we'll do a couple more together. Number 7. The limit as x approaches 1 of f of x, and I'm going to give you that f of x equals, this is right on your paper already, the x plus 2, x is less than or equal to 1, so that'd be from the left hand side, and then x squared minus 6x plus 8 when x is greater than 1. Alright, so we need to check that as we come from both the right and left hand side that we are getting the same value. So I'm going to plug it in coming from the left and from the right. Okay, again, they're the same, so the limit is going to exist, and it's going to equal 3. All right, number 9. Let's see, the limit as x approaches negative 2, and negative x plus 2, and x squared minus 4. Alright, so if we plug in negative 2, you're going to see that we get 0 over 0, which is indeterminate. So we need to use one of our 4 strategies. Okay, it looks like in this case here, I can use factor and cancel. So I'm going to go ahead and rewrite this. And the top will stay the same. The bottom could factor to x plus 2, x minus 2. I factor and cancel. And notice now I could plug in negative 2. So I'm going to get negative 1 over negative 4, which is just going to equal 1/4. Alright, so you try working on the rest of them, and let me know if you have any questions.